moment. It seems as though everybody adds another letter in front of BIM, yet we still don't understand or agree on what BIM is in itself. So I'm actually a buildings guy by background. I'm a structural engineer. I've grown up designing stadiums, and that's given me an access into the world of BIM, and from there I've sort of started looking at the application of BIM all the way through different industries. So I guess the first question that we all need to ask ourselves is, why do anything differently? If it's not broke, don't fix it. Well, it is broke. You know, the construction industry, productivity in the construction industry goes down year on year. And it's crazy when you look at certain aspects of the construction industry, like off-site production, steel industry, precast industry, where those productivities vastly increase. So that even makes the overall construction industry even worse. So why do you do things differently? Is it just because the government tells you to? So the government mandated BIM for all centrally procured government projects by 2016, October this year, 2016, and that's going to come as a wake-up call to a lot of people in the industry. Well, no, actually, that's not the reason. You don't ever do anything just because somebody tells you to do it. There's got to be a reason, and those reasons are different depending on the client you're working for. So, for example, clients could be interested on reducing capital costs. You know, that's a very key thing to most clients, or looking at reduced carbon emissions, or looking at decreased time to practical completion, improved productivity, audit trails. There's a whole series of different things that are key questions for that particular client. And as our jobs as consultants or people who work with clients, it's our duty to understand what is important to the client and actually deliver that for them. So two of the things that are quite key to me and to most people, whether or not they know it, is actually reduction of waste and reducing of the consumption of resources. And the reason for that is this photograph. This is the most iconic photograph I think ever taken by a human being, although it's interesting to say it was taken last century, not this century. But that's Earthrise from the Apollo, and I'm the second speaker to mention Apollo today. But look at it. Wow, one blue marble floating through space, that's our life support system. But yet we consume resources at an incredible rate, way beyond what the Earth can actually sustain. And we continue to do so. And that's going to come back to bite us, and that could be a potential black swan that is going to arise within the next century. So yeah, we continue on consuming resources, we're going to treble the current consumption of resource. And there's a lot of waste, and that's the thing that really annoys me, that in the construction industry there's a phenomenal amount of waste that's generated. Going back, so John Egan, almost 20 years ago, wrote the report, Rethinking Construction, talking about 30% of construction rework, 40% manpower wasted, 10% of materials, 40% late or over budget. In 2009, there was a report called the Wolstenholme Report, Never Waste a Good Crisis, and that said things haven't really changed, to be honest with you, except for the projects that took on board things from rethinking construction excellence, the lean products, where there had been a dramatic improvement. But for the most part, things in the construction industry haven't changed. US Facilities wrote a report called Cost of Inadequate Interoperability in the US Capital Facilities. Bit of a mouthful, but they reckon that $15.8 billion are wasted every year just through people duplicating the same task again and again between different projects. And usually in an audience, when I'm talking and I've got like architects in an audience, are there any architects in the audience actually? One or two, right? So the classic example is, how many times do you draw the structural engineer's columns in your drawings? And the response is, yeah, pretty much most of the time. Actually, it's duplication. And that's just a classic example of duplication, and it happens all the way through the industry and all the way through the different processes. So we look at a product life cycle, a project life cycle, Freudian slip there. They all go through the same cycles. It doesn't matter whether or not it's a building or an infrastructure project. You go through a feasibility, pre-construction, construction, operation, decommission. Now the interesting thing for the construction industry, as a rule, which is different from most other manufacturing industries, that we tend to go through a massive redesign exercise after we've tendered the design and when we bring on the construction team. Because at that point we've actually got the people on board who are actually going to build the thing, actually fabricate and decide, and they want to do it in a particular way that suits their process. So there's a phenomenal amount of rebuild and rework just built into the procedures. And one of the biggest barriers for BIM and for the construction industry isn't to do with technology, it's actually to do with procurement routes. It's about getting the right people at the right time to ask the right questions with the right information. Going forward. For some reason. It was so important I did it twice. Okay, this is the problem, right? Construction industry is. What is going on with that? Oh, construction industry is fragmented. The construction industry is fragmented, and the information, and therefore the information between the different groups, information transfer is broken, and we call this data atrophy. Data literally dies, information dies as it goes through the process. We start concept, we finish concept, we start again for design. We only ever hand over 50% of the information from design that's in our heads as designers onto the guys who are actually going to build it. They then pass over less than half of that information to the guys actually going to operate the building for the rest of its lifetime. And typically that used to be in the format of lever arc files, that's only purpose in life was to prop open a door on a hot day. And now we give them a DVD. And unfortunately a DVD is even less useful than a lever arc file because you can't prop open a door with a DVD. So, you know, there's something broken in the way in which we perceive information and we transfer information as we go through the process. And there's a whole reason for this, about the way we transfer information, about the way we create information, about the way we don't invest in simulations compared to the automotive industry, which only do a crash test now as almost like a final tick in the box. They know exactly how that crash test is going to perform for the safety standards because they've got enough knowledge on simulation. And then we start this final production phase before the design's even complete. So this is one of the results of this. We have a major amount of resource invested somewhere between detailed design and construction, where actually we can't make as much change, we can not influence change, and it costs a lot of money to change. Again, sort of if you're doing a tunnel alignment for a crossrail, for example, at the design stage, if you need to move that tunnel, a couple of meters to the left or a couple of meters to the right, they're easy to do. A couple of mouse clicks and it's done at the concept level. You get through to construction, you can't do that. You're locked into it. So we've got to move where we have the resource allocated further to the left, where they can have the greatest influence and it costs the least to change. And if you notice, actually, what's happened at the bottom of that screen, I've started using different language to do that. I started actually, again, taking from Derek's presentation, I'm using manufacturing mindset. I'm talking about concurrent fabrication and design for manufacturing, and then the final process isn't becoming a construction process, it's becoming an assembly process. And this is where we need to get to. So the answer is BIM. Great, fantastic, we know that. So what is BIM? Well, BIM is a really interesting thing, especially when I'm talking to an infrastructure audience, because everybody says, well, BIM, it's building information modeling, it's not relevant to infrastructure, is it? It's like, well, actually, let's get rid of building. Let's not think about a building as a noun, let's think about building to verb, let's think about the built environment. And actually what we're talking about is assets. And we're talking about assets within the built environment. So let's look at the other end, modeling. Right, okay, so the problem with modeling is most people, helped by a lot of software vendors, think about modeling as being something that is a three-dimensional model. It is a model. Right, actually start thinking about it as being a three-dimensional CAD model, and start thinking it like a scientific model or a financial model. Think of it as a way of understanding how something behaves. And actually, let's not even think about modeling. What we're talking about is management. We're talking about the management of information. So if we had our time again, we wouldn't be calling it BIM, we'd be calling it Asset Information Management, which, considering there's only 3 words in the acronym, we managed to get 2 of them wrong. But luckily, the most important thing we got is right, and it's about information. And that is the key. That is what BIM is about. It's about information. And if you look at the definitions, it's about process. If you look at the definition of BIM, a coordinated digital data set that contains computable information necessary to design, build, operate, and ultimately decommission a project, or you look at what PAS 1192 actually talks about, a process of designing, constructing, or operating a building or infrastructure asset using electronic-oriented information, we're talking about process. We're talking about sharing structured information. And if you take one thing from this for the rest of the day, BIM is about sharing structured information. It's not enough just to share information, but you've got to structure that information in a way that somebody else can use that for doing their process, and therefore eliminate duplication. So BIM is like a subset, if you like, or coming together of geometric and technical simulations. Geometric simulations are absolutely fundamental. We'll never get away from that. We're 3-dimensional creatures living in a 3-dimensional world. We need geometric prototypes. But it's also about project information and about ICT, being able to communicate the information, being able to store it, know with confidence that when you get that information, you've got the latest information and you're making decisions based on the most up-to-date information. And this is what BIM is, bringing all of these things together, making sure that the right people can make the right decisions at the right time with the right information. So, I usually ask this question just to like reinforce a point. So basically, on what I've said so far, should you think that A is BIM a process that conforms, enhances and strengthens your current businesses by facilitating greater efficiency, or B, a software that you choose to impose on your current business because everyone else is using it? Right? So quick show of hands in the audience, who thinks it should be A? Okay, good. Most people. Who thinks that it actually really is B? Yeah. Most in the industry at the moment, there is a lot of jumping on software because software is perceived to be BIM in a box, and it's not about people then thinking about it's a process. Am I choosing the right software? I could choose several different pieces of software to make the right decisions. It's not about software. It is a process enabled by software. It's not the software. And you've seen the view diagram. What's interesting about level 2 BIM, which is where we should be going for October this year, is it's preceded by these other levels, level 0 and level 1. So level 1 BIM is basically 2D CAD, but it's 2D CAD done in a particular way. It's still about sharing structured information. And one of the primary documents for this is BS 1192. BS 1192 gives you information about how to structure information from CAD, talking about layering, talking about naming conventions. And that's really important. And you can't move on to level 2 before we've actually understood the basics of sharing information, how you provide layers between different companies so people can actually use the same information without actually duplicating. And then we go on to level 2. So level 2, there's 8 documents, or 8, some of them are not really documents, but 8 pillars, we call them, of BIM. The first 4 are extensions of that first document, 1192. Some of them are PAS standards, one of them is actually a real British standard, and they deliver, they talk about information on capital facilities, the delivery, information management for the operational phase, information exchange requirements, which is how to structure COBE, how to deal with the security of information. So they're all documents that help you with sharing and structuring information for the purpose of sharing that information with others. Then we go on to CIC BIM protocol, which is a contractual framework, and this is really important document. So just out of interest, is there anybody in the audience who's using CIC BIM protocol on a BIM project? There's one or two. The really interesting thing about the CIC BIM protocol is it makes collaboration an express term of the contract. Right? It's no longer an implied term anymore, it's an express term. And the other interesting thing is it makes a model the primary deliverable. So if there is a difference between the drawings and the model takes precedence. And that's a really important lead in moving forward on how we think about working together and collaborating. There's another document about soft landings, about briefing. Then we've got a classification system, for example, Unit Class 2015. And then recently we've got the digital planner works. So all of those documents together, that is BIM level 2, right? And that is where we should be in the process of understanding all of these for the delivery of government centrally procured projects by October of this year. And then you look at that and you think, actually, the industry's got quite a long way to go in a couple of months. And this is potentially black swan moments. This is moments where people find that actually they're no longer able to bid on centrally procured projects because they're not able to demonstrate that they can work in a BIM-enabled way. And there's a long way to go. So, just before I talk about a real project, the last thing I want to talk about is this idea of level of detail and level of information, because this is another important thing about understanding within the framework of BIM objects. Level of information and level of detail is being handled by this digital planner works. Now, level of detail for building projects is actually quite well defined, and we use an American Institute of Architects document, the IIA document. For infrastructure projects, there is not that body of work out there about helping define at which stage and how developed objects should be for an infrastructure project. So there's quite a bit of work to do on developing the same level of granularity and making sure that people can understand. And eventually this comes back to scope of works. It comes back to what are you being contracted to deliver at a particular point for the client in terms of the structure of information. And eventually, hopefully, the idea is that we're going to move from this idea of clash detection. Everybody talks about clash detection. Actually, the key we should be talking about is clash avoidance. So this is an example. This is taken out of PAS 1192. We talk about, right at the start, in terms of concept, about volumes, about making sure that there's volumes in models, and if you know you're a package designer working within sort of the overhead line electrification volumes, and you spray out of that package, you know that there's potential there's going to be a clash somewhere. Stay within that for your package, and you know there's a chance that you're not going to end up later on in the detailed design of doing a clash detection and finding clashes. So we need to get into the mindset of trying to avoid clashes as we go through the project, right from the start all the way through the project. So I'm very quickly just going to talk about a real project now, which is Crossrail, a project that Arup was involved with, and on multiple sides. We also had staff seconded into Crossrail as well to help set up with the information management. So Crossrail is an amazing project, massive tunnelling project through London, 28 subsurface station upgrades, 8 major subsurface stations, 90 kilometres of network, 21 kilometres of twin-bore tunnels. You know, a massive project. And it's been a success largely through the adoption of information management processes to help with just manage the amount of detail that we've got to do. So the purpose of Crossrail was to increase London's below surface rail capacity by 10%, provide massive, significant regeneration opportunities along its route, act as a catalyst for growth, and provide high capacity links from Heathrow to London's West End, Canary Wharf and the east of London. But what did it actually mean? What did it actually mean in terms of the cascade of project management? Well, think about this example. An engineering requirement triggers an alignment of the tunnel alignment. This then means that the land ownership changes. The requirements for understanding the land ownership for that tunnel changes as a result of that. You may need to buy a different purchase of land. It means that structural engineers then have to go and survey all the new buildings on that alignment, and then transport and logistics teams need to find different accesses to that site. And that's just triggered by triggered by that alignment change. So in order to do this, we've got to bring together lots of different things. We've got to bring together computer-aided design. We've got to bring together BIM from BIM-enabled tool sets, from BIM authoring packages, GIS systems, graphical information systems, project information management, and it looks something like that on the right. We've got all of these different people contributing information, taking information, contributing information all the time over this massive infrastructure project. So what we want to do is move towards the creation of virtual assets. We're not in this idea of, and this is a different mindset as well moving forward with BIM. Clients need to think about procuring digital assets, not just physical assets anymore. They're going to procure digital assets. We've got to set some processes, we've got to integrate all the design, construction and operational life cycles all within this virtual environment and collaborate between all the different parties. But ultimately what we want to get to is this idea, this concept of a single source of the truth, which has got all of the information we need, all of the information so people can make the right information at the right time with the right information. So this is what it meant from a piece of individual data. We are comprised of three elements. We've got the technological development, which we work very closely with Bentley, the adoption of data standards into the information management systems, and leading BIM in the construction. And with each one of these, a single task needed to perform across each three of these things. So each individual task that was associated through Crossrail had to basically report against each one of these three objectives, whether or not it's looking about data mobility or interoperable data, or collaboration tasks or engineering tasks, are reporting against each one of those three objects. So this is an example of the high-level data model for Crossrail. Huge amounts of data, not just technical data as well. As you can see from this, we've got financial data, we've got scheduling data, we've got asset data, and engineering data, surveying data, etc. So this is an example of what this might actually look like. Remember when I was talking about before about changing the alignment. So these dark lines you can see on the here on the graph. They represent the tunnel lines, settlement lines, and we've identified there is a building within that. So using the GIS system, we're able to pull out information about that building. We're able to pull off photographic information about that building, find out who owns that building, pull out any surveys or ownership correspondence. Everything related to that building can be pulled up from this database, from cross-referencing using the GIS system. And it's basically just a means of accessing data so that people can make decisions with the right information. So this used a browser, so it wasn't a bespoke piece of software. It was designed to run within a browser, so you didn't need to install a piece of software on your computer. You could just run a browser to access this information. And the types of tools that were integrated into Crossrail, 2 and 3D CAD, GIS, visualizations, data management, office applications for calculation and communication, specialist software for settlement analysis, data document management systems, engineering content management systems. All of that information was pulled together on the system and with an idea of enhancing processes based on BS 1192 principles for processes, based on collaboration, based on this concept of a single source of truth. I feel as though I'm going to be, am I running out of time? Yeah, okay, sorry about that. Okay, so what I'm going to quickly skip through these. The slides will be available for you to look through, but I guess the key thing that I wanted to get to, I'm just going to go down to, because I just want to finish with one slide. This is talking about asset management and how asset management was delivered for it. These are examples of the cost, but this next slide, this next graph is really important. This is a really important graph, and what this shows is return on investment. So what we've got with the graph is the black line at the top is the black line there is the time it takes to traditionally do a task. Any task, like pull off the information or go out to a building and survey information or find a photograph or make sure you've got the latest information. The orange line beneath it is the time that it took to do the task once we've implemented this database system to be able to cross-reference GIS information. So each time there is a request for information, there is a saving, and the client makes money because of that saving. And that's just direct cost, that's not indirect cost through making the wrong information at the wrong time. And the red line you can see going up there is the return on investment. So it's negative to begin with because you've got to invest in the system, and you've got to set it up and you've got to train people to use it. But pretty quickly you're into the process that every time somebody makes a request for information or gets information, you're making a saving. And that return on investment is continuous throughout the whole process. And this is the power of putting in place and thinking about information-centric processes, having information and sharing structured information right at the heart of the process. You very quickly get your return on investment back, and you make gains for the client, on behalf of the client, on behalf of the teams who are working for it. Okay, so thank you very much for
beyond building, and how can we integrate, or what's the rationale of using BIM with GIS and other tools? And the examples the Martin just gave us is actually very good examples of integration or integrated use of BIM with GIS. Based on the level 2 BIM protocol standards in the UK, which are actually for building sector, but they're implemented for highway project, for infrastructure project. It means this sort of practice and experience and lessons learned will actually build up over time, and then possibly the BIM protocols for infrastructure projects can be also produced in the near future. So that's also very useful, and also actually give us the good understanding about using BIM with other technologies such as GIS for infrastructure projects. Now I'd like to invite Paul Bryan from Historic Building Environment to do his presentation. Sorry, Historic England. I'm sorry, Paul. It's a new institution, so he's also give us a presentation about BIM and heritage. Are they a good match? And he's also touched upon some of the technologies they use, or they think that we have to use in the historic environment management. Yes, Paul.
Back from your coffee, so I'll try and sort of skip through this fairly quickly because I need a cup of coffee myself. If I actually came last year to talk to you, I would have actually been wearing a different hat. I would have been wearing the hat of English Heritage, and as you can see from that, English Heritage was the English government's principal advisor on all aspects of the historic environment. On the 1st of April, English Heritage split in two. It wasn't an April Fool's joke, and we now have English Heritage, or English Heritage Trust, as we're now officially calling them. And the important thing there is that they're an independent charity as opposed to having the government's link. And they maintain the National Heritage Collection, which is effectively all of 400 historic properties that you pay the money, go in Stonehenge, there's a Dover Castle, etc. The remnants of the split were sort of brought into a new organisation called Historic England, which continues with the government's link. It's the Independent Expert Advisory Service for the England's historic environment. And so hopefully both of you are aware of the two organisations, and there's quite a lot of synergy, to use that sort of term, between the two organisations. But over the years, the heritage will become more and more separate to a sort of independent charity. I currently work within a remote sensing team. I'm a surveyor by profession. By surveyor, I mean land surveyor. And I work with teams that are involved in aerial survey, geophysics. So we've got people looking at the Earth's surface or England's surface from the air, from underneath. And I manage a team, a fairly small team now, following various restructurings of 2.5 people. And you can see there straight away that we like to use the modern sort of gadgetry of surveying. That's a Leica P40 laser scanner that we use for some of our projects. What is BIM? We've already had a what is BIM slide already, and I'd imagine everyone in this audience should have their own definition, but I bet you it's not the same as mine, and you know, we won't all have one definition. I've actually been quite lazy that I've actually sort of chosen a definition that one of our survey contractors actually put together, because they're people that are in the commercial environment. They're actually using BIM to make money, effectively. And you can see there the two buzzwords, collaboration and life cycle of the building, which I think, you know, BIM, if you put to one side, you know, you sort of your own views on it. It is about collaboration, the sharing of data, and the idea is once created, it's not sort of put on the shelf, it's to actually sort of help you maintain the building whilst it's there. It's also a process of illustration in digital terms, all the elements that compose a building. It was very interesting listening to John's talk. He asked the question, is he alone in his views? I think you'll find that I'm with him in terms of the views that he's put across. Apologies that my slides seem to be getting cut off by this projector, but those of you that know David Philp will probably recognise that. It's not a matter of if, but when your firm will implement BIM. You might want to ask that question of Historic England over coffee. Are we implementing it? And I'll give you actually a fairly sort of straightforward response. We've heard a little bit about the sort of BIM, Building Information Modelling Task Group, but John also mentioned the BIM for Conservation, or BIM 4C, working group that was established in 2014, and that follows on from the very good pioneering work of Kotak that John mentioned already. And the idea there is to actually raise awareness and understanding of BIM within the conservation and heritage sector of the built environment. And even though we've heard various acronyms already, I'm already putting together new acronyms on the fly. Like we could even talk about historic environment BIM or built environment BIM. But it's also promote the benefits of a BIM approach when you're actually maintaining existing buildings still. So what are Historic England and English Heritage doing about BIM or doing with BIM? Well, I first encountered BIM in 2009 when I attended a conference over in America, and I was the only person in the audience that hadn't heard of BIM before. Everybody else over there was talking openly about it. So I came back to the UK and I sort of mentioned it to our sort of senior management. We like to develop special interest groups within our organisation, so a BIM special interest group was formed called BIMC. But the important thing there was that it was actually a collaboration of different roles and expertise that all feed in to a typical heritage project. You've got the estates managers who actually sort of manage the buildings. You've got the sort of heritage protection and planning people. You've got archaeologists and architects. You've got remote sensing people like me that are focusing on not just the sort of geometric technologies, but technologies to understand the actual fabric itself. But then you've got conservation and science people, and most importantly, archive, because if you're looking to actually maintain or use this for the life cycle of the building, you've got to think about how that data is going to be sort of stored, managed, used, is made accessible. Historic England have the what used to be called the sort of National Monuments Record down in Swindon, so that to us is sort of the obvious repository for information like this. However, at the time, English Heritage were actually formulating their own science strategy, and this was linked to the National Heritage Science Strategy that was being sort of promoted by the government. So one of the things that I was able to do was actually get BIM actually included within the Heritage Science Strategy, because once that was in there, people could actually see how it worked alongside all the different sort of heritage science approaches that are typically used. So the actual BIM SIG that we created, it's aimed to assess the relevance of using BIM processes across English Heritage's own estate. You can see it's sort of a very simple diagram of all the different properties. But one of them that I sort of want to focus on is maybe one that you haven't heard of before. It's actually Harmansworth Barn, which is on the northern side of Heathrow Airport. A very important and significant historic building, 15th century. Largest intact medieval timber frame barn, and you can see why it's been done as a cathedral of Middlesex because of the fantastic interior space. However, as a sort of heritage building, it has suffered over the years. It was in sort of private ownership previously, struggled to actually sort of maintain it as a typical building would need, so it came with a load of structural and conservation problems. English Heritage stepped in 2012 and acquired it, and the idea was to sort of address these issues, but it came with sort of a body of information that had been collated already. I suppose within the sort of the BIM terminologies, this might be BIM level 0, touching on the BIM level 1 sort of data. In 2012, English Heritage acquired its first laser scanner, so I managed to get the project managers to agree for us to actually supplement this existing information with three-dimensional data created from laser scanning. So from that, a whole series of outputs were generated that would help the actual conservation project, and this data has already been used by the engineers, the region have to maintain the building, and the organisation itself. You can see some of the outputs that have been created from them. We've also used it for educational approaches through an organisation called SIRE, which was founded by Ben Cassira. But for a site like Heathrow Airport, that is, sorry, not Heathrow Airport, Harmansworth Barn, that's potentially under threat by what might be happening at Heathrow Airport over the next sort of 10 years or so. We have a sort of a body of information that would help us sort of maintain it up until 2025 if it goes ahead, or even sort of use it to sort of relocate the building if it needed to go there. The other sort of monument that I want to sort of throw into the equation, which is not your typical existing building or structure that when you think of BIM. Iron Bridge, I'd say most people have heard of the Iron Bridge and its iconic sort of status, World Heritage Site. Various epochs of survey being undertaken, as I say, probably the sort of level 0, potentially level 1 type of BIM data. So we've got that information already. But a need to actually assess the structural stability of the building brought in a need to generate new data. This actually was included in a very detailed report by Rambolds, who's an engineer. They did a desk study, modelling analysis and assessment. And within this, they actually created all of the geometric components that could make up a BIM model of the Iron Bridge. I'll touch on this sort of in a little while, but it was an opportunity that we could sort of use existing data and new technology to help us sort of manage that structure. As it says in this following slide. And of course, with laser scanning, you've got all of sort of the ability to sort of animate the point cloud data. although I must admit that's getting a little bit old hat now, because we're probably into drones and sort of flying drones around a site like that to capture, imagery similar to that. The other area of the work of BIMC was English Heritage and now Historic England. They have to deal a lot with the external sector. People are actually coming to English Heritage and Historic England for advice. And of course people sort of pick up on these buzzwords. Laser scanning was one that we corrected. People were commissioning laser scanning without actually thinking, do you actually need laser scanning? BIM has started to appear as well. So we have projects like this regeneration project in Nelson, Briarfield Mill, Grade 2 listed mill building. There, the term BIM was brought in very, very early on by the actual architects who wanted to actually regenerate the site. Fully laser scanned site, lots of sort of nice animations, but a BIM model was actually created for the entire site. The only drawback with that is that you haven't got continuity typically in people sort of using this data. So you had a new body of architects commissioned who obviously didn't like BIM. And so they started to pull it apart. But if you actually look in detail, part of me is thinking, well, they're actually saying sort of correct things in that the data to help within a BIM environment, it needs to be complete. It needs to have all the sort of the architectural information attached to it. So these were things that we've had to consider within our work. The BIM task group has generated various client guides. One of them is about 3D scanning and data capture. And if you're talking about the technologies that feed into the geometric side of BIM, people tend to say laser scanning. And it's quite ironic that the client guide says 3D scanning. I think John touched on it earlier. Do you actually need laser scanning? There are other technologies out there. You've got existing data that you can reuse. You've got existing imagery that you could reuse within photogrammetry. You've now got this term called structural motion photogrammetry that a lot of people are getting very excited about it because it's cheap. And you can actually use it pretty much for free using various apps that are now being generated by the likes of Autodesk. But that's a little bit of an issue for myself. Don't just think about laser scanning, think about the actual data that you need for your project. We deal a lot with commercial contractors. The majority of the data for English Heritage, survey-wise, is procured externally. And there we're dealing with contractors that have well and truly got onto the BIM bandwagon, and they're actually sort of setting up BIM teams to actually make money, as I said earlier. Our team within Historic England is small, and so when we actually commission work to outside companies, we have to tell them what it is that we want. So in terms of procurement and standards, we use a framework agreement for commissioning this work. And I mentioned there low-level aerial photography, typically acquired from drones. There are other ways of getting the camera up into the air, low level, but drones are being sort of picked up very quickly by people. And for anyone who's actually been in Tesco's or Degrade Smith's, you might see Drone magazine appearing on not the top shelf, but on some of the shelves within the sort of the newsagents. There's an article about our use of drones by Historic England actually in the current edition. So if anyone's interested in using drones, you might want to look at that later. But as I say, we need to actually tell contractors what we want, and we've been using a specification for a number of years because we want to get the right survey for the right job at the right time. The actual specification is in a number of editions now. It was originally published in 2003. I wrote the first version. It was revised in 2009. And we've recently revised it to include the widespread use of laser scanning, digital imaging, drones. But we've also included BIM. And we wanted to actually include BIM because BIM shouldn't be seen as sort of a separate entity. It's a process. I think I was one that put my hand up for the process there. So we want to actually have that process work alongside all of the geometrical data generation processes that are used. And you can see an example there that's been created by one of the external contractors we use. BIM, as well as being full of acronyms, it's full of levels as well. And here on the slide, you'll see we've got level 1 to level 4. This is talking about the level of detail that a BIM model needs to create, because not every project needs the all singing, all dancing, show everything level of detail. Some BIM models simply need to have the typical sort of boxes created to help whatever analysis is required. I'd highlight the importance of fabric information there, because if you're using BIM for analytical purposes, you need to make sure that you're using the right fabric information and not just a component pulled off the virtual shelf of Revit or BIM. So what other work are we doing? Well, Historic England is trying to generate new understanding about BIM within a heritage or historic context. We've got 2 research projects about to kick off, about to start. One of them, University of Salford, know all about because they tendered for it. This is a collaborative doctoral partnership with AHRC. And the aim of this project is to investigate how a widely used IT system, etc., as you see on the slide there. It's a long 3.5-year project, and it's been awarded to University of Reading, and the advert for the studentship is actually out now, so people can actually apply by the 22nd of April. But this is quite an interesting project for me because it's a long-term project. I know how things can change, particularly in survey. So an important part of this studentship will be to make sure they listen to people like John Edwards talking about the heritage application, people like Arrows talking about the technological side, so that we actually can create these research outcomes that are current and up to date, not just old and out of date when they're published. The other one is a much shorter process, and it follows on with the heritage science link. And this is actually looking at both Harmansworth and Ironbridge data that we have already, but focusing on the heritage science and conservation aspects. So this is a short-term project that is about to start next month, finishing around about November time next year. But as well as generating BIM data sets for both sites, we want to see how those science processes and the conservation processes both fit into the BIM workflow, but how people in that area can benefit from them. So, from the title that I said, are they a good match? Possibly. I think I'm more in favour than against it, because there are definite advantages for using BIM. Improve spatial analysis, generate outputs from it, visualisation side in particular, people are very interested in to see. And whether we like it or not, the UK government is probably here to stay. They keep pushing it, I think. The downside of it is that BIM, well, some people think it is a software, people think it is Revit, it obviously isn't. They're just tools to actually help the process work. But the problem it faces is that it's come from new build design. It's trying to fit what are irregular features you typically find heritage into a regular box. So you're trying to squeeze all that detail in and trying to make sense of it. This is where I'm maybe with the likes of John in maybe thinking about not new softwares, but new ways of using the data within those softwares, working with the likes of Autodesk, Bentley, to make those tools fit heritage better. But architectural depiction takes time to model, and all of this takes a lot of time and money. So in summary, another acronym to throw in, BIM, is it simply better information management? If you ask English Heritage, are they using BIM, they will probably say, well, we're still thinking about it. That's because they already have an information management process in place that gives them some of what they need. Gives them a lot of what they need to maintain those buildings. They're considering BIM, but the adoption of BIM is still low. I agree entirely with John on that. But if you look beyond the boundaries of the UK, other countries are sort of getting involved in BIM in fairly big ways. So, you know, so some of our issues are looking, you know, beyond the boundaries to sort of see how we can learn from other people. Historic England and historic English heritage, they're still considering BIM and how they might utilise it. Talked about the irregular features, aspects. And as I say, I think the I word within BIM, to me, is probably one of the most important bits, because if you get the information correct, the fabric information correct, it starts to make sense why you're generating BIM. If you want to look at sort of thermal performance of a building, if you've got the information correct, then you're getting sort of valuable data out of it. And then, at the end of the day, can we afford it? As John said, sorry to keep reminding you, using your name again, John, but some of the organisations probably struggle to maintain the buildings, let alone to sort of model it to a higher tolerance. So can the heritage sector actually justify it? I think within certain projects, yes, it can. But I think, you know, research like we're doing and collaborative research like is done throughout universities is maybe the way forward within all of this. So many thanks for listening, and apologies for sort of keeping you back from your copy. And that's the link for the specification document if anyone wants to download it, because the PDF is free. Okay, thank you very much.
For electrification, signaling, and so on. So there are three types of groups working together to make sure that it's going to be constructed. They have to somehow interface with each other. Initially, you might want to then reconstruct your rails, then obviously construct. So this is more than building information. For building sector, you need to think about the construction at the same time construction as well. So there are lots of heavy process going on, civil engineering, excavation, taking rails out, plants are moving in, taking some of the stuff which are removed from the tracks into the train, and so on. Again, when you try to do a project like this, this is going to disrupt your the passenger movements and so on. So you need to plan your activities so that at a certain time, certain trains could go past that particular activity, so everything has to be somehow moved out of the way. So there also thinking needs to happen within that space. So let's imagine you're the planner. So you need to think about what the site looks like, what sort of activities need to be planned. So it's a complex set of engineering activities that you need to think about in time and also in space. And also you're working with a range of group of people who are planning, the QA, OLEs and signaling and so on. So you need to build a common understanding about how it's going to work out. And sometimes, in this particular case, since you are moving and bringing trains between plants and so on, you need to make sure there are no clashes. There's enough space to carry out that particular task. So the space requirements is very important. And also think about, sorry, I've got a problem with my sore throat, so I've got exclusion zones, and also access points and so on. And at the same time, within network rail, our experience has been you get a schedule done, but it keeps changing until the last minute. So you need to make sure that your plan could be interactively changed and adopted, and also eliminate waste, reduce cost, and also thinking about this efficient program. So when you think about the existing kind of practices that we observe, the network rail is the planning is done around 2D drawings. Sometimes what you do is you use static PowerPoint slides to demonstrate how where the tracks is, how the plant is coming in, then taking the tracks out, for example, and then animating in a kind of 2D fashion. And also, some of the teams within network rail has gone beyond that and tried to create 4D animations. So the 4D animations could be using animation program, taking that particular schedule, and then creating a visual representation of how it's going to be done. The problem with that approach is, as I said before, schedule is changing very rapidly. So if you've done animation, then the team has to send that changes back into the animation group, could be third party, bring that back again to the kind of to the planning process. So as a result, there's no seamless interaction between the model and the team. And also there are some tools within the construction site, construction domains, like talking about last plan, Synchro is another one, where then you can think about thinking about remodeling your particular activities over time. In these particular cases, most of the time people are looking at kind of Microsoft Project Live or Computer Live and so on. So this is the particular ones thinking very much about time, so the task and time, but there's no space concept built into that thing. So imagine you're a planner, you're planning task, but it's not really related to where it is that particular task happening and so on. So things like Synchro, for example, there you can bring that model, then you have to prepare that model. You have to break it down into a set of tasks so that you know that on day one, particular things will be a model constructed and so on. So you have to take the BIM model, for example, then break it down to a set of steps to do that. So you have a complex application interface where you select one, then attach that particular task into to your project plan and so on. So you can begin to manually program how this is going to be constructed. At the same time, plants, you can have like animation package. You bring your plant that you need and then define the animation task. Again, this is, as a planner, you need to think about what's the planner's thinking model. Or this much, this particular type of approach will demand sort of more IT approach, understanding about manipulating the CAD and so on. But as the planner, perhaps this is a bit more remote from the way thinking. So in ThinkLab, what we've done is we're looking at systems where you have kind of three types of interfaces. At the top, this is where your site is, so you can bring GIS data, terrain, aerial photograph, and so on, and build your site. And then you bring your BIM model into that, so you position, you set your virtual site to think about. So as a planner, you've got a virtual site in front of you. Our next task is to think about what are the tasks, what are the resources you need to particular task. In here, we have something called time distance metaphor. So that means on the bottom, what you have is the change markers that define your position within that terrain. And this is on the vertical side is the time. So you're thinking in terms of time and space. You say, okay, I want a particular plant to go from this particular change marker to over there. So at the same time, you can define for your object to have a performance. Yeah? So that if you define your from A to B, and you know the performance of how fast that you can move, so the time could be automatically calculated. So this particular bottom pane, for example, it allows you to define your task. And the middle one is where it's like a schematic diagram of your tracks, so that you can really see how the tracks are on the way. So it's very much about kind of model-based kind of approach, where each plant will have a performance cost associated with that. So you can calculate automatically time and the cost for conducting that particular task. So in order to reduce the burden of from the plan, so what you have to do is to build some sort of intelligence behind the model, take a big model and thinking about, okay, once you get the tracks, so how do you make sure that connection, the logical network could be built automatically. Then, for example, if you define that particular plant should go from A to B, so the system will automatically identify what's the path to go there. So it allows you to kind of do path planning automatically. At the same time, once you define the task, it will do the task simulation for you to really see. As you plan, you can see on the side, those activities are happening. Now what I'm going to do is to demonstrate this particular system using video. So this is our 4D simulation environment. Unfortunately, this particular one is a bit slow, so to do a better video presentation. So as you can see, so this is where at the top, this is where the site is, and at the bottom, this is where the time distance diagram is. So initially, once you define, you can I'll tell you how to do the design in this video. But once you've done the design, it gives you different camera points. You can have a bird's eye view to understand how these are happening. You can be the train driver and really see how that person is happening. Or if you are somebody on the site, that views could be manipulated. So at the bottom, this is where task planner, this is where the task, the planner will be thinking in terms of task and so on and so on. So again, this is an interactive kind of a view. So in terms of viewpoint, this particular one trying to show that if you have lots of activities over time, you can zoom into that particular activities and really see what's happening. So obviously this is very slow. It allows you to accelerate, speed up, and really see, okay, how the activities are happening, are there any clashes, and so on. So once you've done that, this allows you to then, this is showing how you define your resources. So you can imagine that you need different types of trains or something. You define what resources in your activity. You build up your resources from a resource kind of library. So these are, as I said, an intelligent object, which allows you to then create this kind of resources that you need to apply. Then you can say, okay, I'm going to create a task, and you know what sort of resources you need. So let's imagine that you just want to bring the position of your train to a particular point and ask it to go from A to B. So it defines using simple approach. This is a task again that allows you to define the different types of representation. So you may say move operations could be red. So you can give a color code so that you know in the task, this particular task are color coded, and also you can attach some information on that. So once you've done that particular task, straight away you can see on the side what that task is happening. So and make sure that it is correctly kind of modeled. So then what you can do is it can also allow you to define another series of activities and allows you to make dependencies. So here there's another one. It's trying to define. So you might want to modify this schedule, bring another task. In this case, it's taking the rails out. So you bring in that particular plant for your task. Then you define where it should start from and so on, so that straight away the task is there to say that the start should happen the previous start. So straight away you can imagine that it's happening. This particular red line is something you can drag and go into the area of interest. This is the second task really happening on that. So visually it's taking the rails from the position. So you can speed it up, and then you can see that the tracks are being removed. So that allows you to create, it's very much like a visual language, right? So that you don't, you bring the unit to more visual representation to make it very simple. It's very user-friendly, suitable planners for briefing session afterward, improve class detection, manage delays during construction. So you can have immediately if there's a change in the planning, just go there and change that the type of plant types or something. You can see that things straight away. Even during construction, that could be adopted based on the changes that you experience within that within the site. So what we did was, then this was shown to Network Rail. It was done with some of the colleagues in Network Rail. Then it has taken a lot of interest. So in order to calculate this, calculate this, they brought a team of people from the South Alliance, SNC South Alliance, and then asked 2 young people to be introduced the systems within about 30 minutes, and then asked us to do a real project called Court Hill South. So this is about how easy it is to use in terms of training. So I'm going to, because of the time, I'm going to go a little bit.
Deliver more for less as part of the railway upgrade plan. And in track renewals, this is what we need to do. We've used in the past PowerPoint staging diagrams that show you a sketch of how we're going to complete millions of pounds worth of infrastructure changes to the minute. We have used 4D modelling that shows you a video of what this will look like. But what we need to do is what we have here. This is different. This is a 4D planning package that allows us to plan in that 3D environment, to actually construct the way that we are going to build this with all the logistical and dimensional constraints that we have on site. This is different. So we wanted to see how different it was. We gave this tool to some of our planners, and this is what they produced in 4 hours. Here, you can see them putting our actual plan into the system, checking it in the system, and then this is what it looks like. Imagine sitting down with the groups and showing this is how we're going to build it. And here's the other variant that we did as well. You can see the plan, and you can see how it works. This gives us confidence. This is a planning package for now that will take us into the future.
Today we've come up to University of Salford to work on the package that University of Salford and Network Rail have been developing, and we've used it to plan Port Hill South, which is a job the SSC Alliance will deliver in week 42, 2017.
Generally, when we develop a job, it takes about a week in using Microsoft Project and PowerPoint. Today, considering that we've never used the software before, we've been able to do half a core weekend in 4 hours.
We see this tool being used as a planning tool right through 2 years out, planning a job, through to delivery, and we see it as the base delivery and the key tool as well.
I think as this program evolves, we're going to be able to do things like track changes, which can add to our health and safety files, our risk registers, help apply with CDM regulations. The possibilities of this program just unlimited.
When I come up here, I was quite surprised to see how well Catherine did getting on with the system we've been using. It has blown me away, but I come up not expecting to be as good as next course. I've been around for the last 17 years working in track renewals. For example, at Reading, there was 5 pieces of equipment inside about 100 yards of track. Basically, it just didn't fit. With this package, we can show crews straight away that 2 to 3 pieces of equipment is more efficient to do this job. My initial thoughts on it was it would be good for massive projects, but I can actually see the benefit of using the small weekend renewals.
So that's the 4D planning package that Salford have developed here with Network Rail. And this is just the start. These guys have just done this in a few hours. Imagine what we could do if we track this for a whole year. This is the start of real planning, future to deliver more.
So currently now this has been going to be used in initially about maybe 10 projects across the UK. That we're also observing or collecting additional things. For example, if you imagine you want to think about what is the disruptions to the neighborhood, so you can do noise pollution, for example. Could we think about the pollution source, so that make sure that you can have as the plants are moving, make sure the safety aspect is not compromised. And also, you can think about in the networks, so that you can bring the lighting aspect. So this is based on a gaming environment called Unreal. So Unreal allows you to visualize. So we build intelligence and program around that, looking at the process, the way the planners think, looking at the current process and make sure that we be enhanced. So I'll just an example of the use of BIM in coding techniques.
I think that's a good evidence that the BIM can be actually quite practically used, for infrastructure projects, and although it's actually maybe one of the very first one of being used for the planning for an infrastructure project, but that's actually quite stimulus and actually giving a good optimistic perspective that it is possible, so we can actually go beyond buildings and to infrastructure. Thank you very much. So that's actually quite eye-opening presentation. So I'd like to invite Professor Bill Getting, please, from University of West England. So he's going to give us a presentation about StopCheck, the challenge of achieving low carbon performance in a changing climate.